Hey, how's it going, everyone? This is I Am Error, and I'm back with another tutorial on game development. And in this video, I want to go over a popular feature found in most modern day action platformer games, where if a player's jump height doesn't get them on top of the platform, the player will still be able to grab the ledge, and then from there you can either have the player jump on top of the ledge or fall down from it. I've come up with a solution that'll have all the meat and potatoes for ledge climbing on one script that we can attach to the player, and then we'll create another script that's going to be more or less empty, and which will attach to whatever game objects we want to use as platforms that the player can climb on top of. The solution I'll go over in this video is also pretty modular, in that you can use this solution for whatever game that you're currently making, and it won't require you to use any of the scripts that I've already set up previously for this video. On that note, if you do in fact want to use the scripts I have in this video, I've provided a link to my GitHub page that'll include every script found on the player, but I'm hoping the solution that I provide in this video can work in anybody else's project. Now, real quick, just to make sure I'm covering my bases and not wasting anybody's time, I'm not going to be going over any of the scripts I've already discussed in other videos. However, if you want a better understanding of how those scripts work, click on the recommendation at the top of this video to check out my total jump solution tutorial, in which I discuss those scripts, as well as of course provide a very complete jump solution. So without any further delays, let's go ahead and get started. The scene I currently have set up is pretty basic. It contains a standard main camera, a standard platform game object with the sprite render and box collider 2D components. I also have two other smaller platforms that are the exact same thing as the ground platform that also has a nearly empty script named ledge. This ledge script only contains two variables that we use to adjust the player position when they're hanging from a ledge. This will also help a script located on the player find which game objects would act as a ledge. I also have a 2D character. The character is fully rigged with IKs, and if you don't know how to set up a 2D character with IKs, consider watching the video I made in which we make this character by clicking on the suggested video here. Now, as I mentioned, we won't be discussing the character, horizontal movement, or jump scripts, so let's go ahead and open up this ledge locator script found on the player, and I'll go over the script from top to bottom. Now, this ledge locator script inherits from my character script, and what the character script is actually doing for the ledge locator script is it's setting up references for the collider, rigid body, and animator components. So if you're not using any type of character-like script that the ledge locator script can inherit from, this solution will require you to set up those references within your ledge locator script as well. Moving right along, we have 6 different variables. We have 2 public variables and 5 private variables, and for these 2 public variables, we can make them serialized field protected or private variables if you want. I have them set as public variables here because I know a lot of new game developers don't really understand what that means. But this solution doesn't require any of the variables within this script to be accessed outside of this script. However, these variables need to be set up in the inspector window. So if you want to make these variables serialized field private or protected variables, go right ahead. For those simply following along, the first variable is going to be an animation clip variable, and we use this variable to get an accurate amount of time in seconds for the climbing animation. The second public float variable we have for climbing horizontal offset is how far inside the platform the player needs to move when they're standing on top of the ledge, and depending on your animation you may want to move your player more or less, but this solution will require that the player be moved slightly inward on the platform so they can actually stand on top of it, but this is definitely a value I'd prefer to set up within the inspector window. Moving right along, we have our private variables now. The first one is a private vector2 variable named top of player. We'll be using this top of player variable as an origin point for our raycast, and depending on whether or not the player is facing left or right, the vector2 value will either be the top right or top left of the player. Next, we have a private game object variable named ledge, and this will be a quick reference to the current platform the player is colliding with that can act as a ledge. Next, we have a private float variable named animation time. This float value will be how long in seconds the ledge climbing animation is. And if you don't have a ledge climbing animation plugged in the inspector window, we hardcode the value as 0.5f so that you can still run the logic within this solution. Next, we have a private bool variable named falling, and all this variable is going to do is stop the player from grabbing onto the ledge again if you want to go ahead and fall down from it. And then last, we have the private bool variable named moved. I'll explain how this bool will work later on in the solution, but this bool is going to work with the ledge script and help protect the player offset when they're hanging from a ledge. Now, because I have a character script, the player collider, rigid body, and animator components are already defined as references through that. So if you're not using a character script and you need references to those variables for the ledge locator script, I went ahead and typed out this optional pseudocode. So for those who aren't following along with my solution and don't have a character script, go ahead and remove all the markers that make this pseudocode, and then delete the initialization method I have right beneath the start method. And then you'll also need to go through this script and change every reference of character.grabbingLedge to just simply grabbing ledge. However, if you do have a character script and are following my solution, you can go ahead and delete all the pseudocode if you want, but if you want to keep it in there, it won't affect the logic either way. So again, this green pseudocode is a convenience feature for those who are trying to use this script as a standalone solution, and if you are using this as a standalone solution, don't forget to delete the initialization method right beneath the start method, and then change every reference of character.grabbingLedge to just simply grabbingLedge. But for those who are following the solution that I provided in previous videos, then you can ignore the green pseudocode and you don't need to worry about changing anything at all. This next protected override void method initialization is going to be for those who are following my scripts in this solution. The initialization method is being run by the character script on my solution, and how it's working with the ledge locator script is it's setting up the variables for the collider 2D, the rigid body 2D, and the animator components, and that's what this base.initialization is actually doing. We want to expand the initialization method for our ledge locator script to check to see if the value in clip is not null, because if it isn't null, then we want to change the value for animation time from the hard-coded value that we put in for 0.5f to however long in seconds the animation clip is. Next, we run the fixed update method, and I have this set up as a protected virtual void method. I typically use a lot of virtual methods when I inherit from other scripts, but if you prefer, you can also make this a private void fixed update. It really doesn't matter. The fixed update method is going to run two different methods. The first one's called check for ledge, and like the name suggests, it's going to manage looking for the right game objects that it can grab onto as a ledge, and once the player finds a platform they can grab onto and enters a ledge hanging state, then the logic found in this ledge hanging method can go ahead and flow, and the ledge hanging method will manage putting the player on top of the ledge or allowing the player to fall down from it, depending on whatever button you press when you're hanging onto the ledge. Let's go ahead and take a look at this check for ledge method from top to bottom. The first thing this method is going to do is ensure that the falling bool is set to false, and the reason we have to do that is because if the player's in a ledge hanging state and you press the button to have the player fall down, the check for ledge method will immediately put the player back in the ledge hanging state because the player will still meet all the criteria to grab onto the ledge. So we need a bool that will manage whether or not the player is falling down from the ledge to stop the player from immediately grabbing back onto the same ledge. Assuming the falling bool is set to false, we then check what direction the player is facing, if they're either facing right or left, and all the logic within this if statement right here will run when the player is facing right, and of course all this logic within the else statement down here will run when the player is facing left. Now because the logic between this if and else statement is similar, I'm only going to go over the logic for what happens when the player is facing right. First we define the position and world coordinates of top of player, and we use the player collider to get world coordinates. So this col.bounds.max.x is going to be a position on the rightmost part of the player collider. We then also add a very tiny offset of 0.1f just to ensure that it is in fact outside of the player collider. And the col.bounds.max.y is going to be a position on the very top of the player collider. So this new vector2 value is going to be the very top right of the player collider plus that tiny offset to the right. We then shoot out a raycast hit 2D that'll go ahead and originate at the top of player position, and then we shoot it out rightward because the player is facing right and that'll be in front of the player. And we don't want this raycast to shoot out too far in front of the player, so we give this raycast a distance of 0.2f, which will basically appear as if it's right in front of the player. Next we run an if statement that checks to see if that raycast hit 2D collided with anything, and within the same if statement, we also check to see if it is colliding with something. We make sure that something has a ledge component attached to it, and if the raycast hit 2D is colliding with something that meets those two conditions, then we go ahead and assign that game object as the current ledge. After that, we run another if statement to make sure that the player's in a position that would make sense to grab onto the ledge. First, we need to make sure that the top of the player collider is lower than the top of the ledge collider. We then simultaneously check to see if the top of the player collider is above the middle of the ledge collider, and this would basically be the sweet spot in which you could hang on to a ledge. So if both of those conditions are met, we go ahead and enter the ledge hanging state by first setting the character.grabbingLedge bool to true. And again, if you're not using a character script, go ahead and say the grabbing ledge bool that you have in this script is true. And then we want to go ahead and run the animation that we have for ledge hanging. As I mentioned, I'm not going to go over the else statement because it's running the same logic. It's just checking for things in an opposite horizontal direction. Underneath the else statement, we have these if and else statements. This if statement will first check to see if ledge is not null, and then it's going to make sure that the grabbing ledge bool is set to true either on your character script or on this one. And if both of those conditions are true, it'll first run the adjust player position method found within this script, and I'll describe that method later in this video. It'll then go ahead and cancel any movement within the rigid body component by setting the rigid body velocity value to vector2.0. Next, we want to change the rigid body type to kinematic, because this will prevent any physics being applied to the player, which will prevent the player from falling. Next, we make sure whatever script that contains horizontal movement logic is set to disabled, so that while we're hanging from a ledge, we don't have the character moving left or right in a floating position. However, if ledge does equal null, then we set the rigid body type back to dynamic, as well as we want to go ahead and set whatever script handles horizontal movement back to enabled. Let's go ahead and scroll down and take a look at the ledge hanging method. In order for any of the logic in this method to run, the character.grabbing ledge bool needs to be set to true, and then this script will check for input detection. And if you press up, it'll go ahead and have the player climb on top of the ledge. And of course, if you press down, it'll go ahead and have the player start falling. So first, let's take a look at what happens when you climb on top of the ledge. It'll first stop playing the ledge hanging animation, and then it checks whether or not the player is facing left or right. And it does this because it needs to know whether or not the player should move to the right or left when they climb on top of the ledge. Once it determines what direction the player is facing, it'll go ahead and run the coroutine climbing ledge. And this coroutine takes two different parameters. One is a vector to position, which the x value will be the player's current position plus whatever the climbing horizontal offset is, and this value will be how much the player needs to move inward when they climb on top of the ledge. The y value is going to be a position on top of the ledge, plus the bottom half of the player collider size y value, which when you add up these two values, it'll position the player perfectly on top of the ledge. The second parameter the climbing ledge method will need is the amount of time in seconds it's going to take the player to get on top of the ledge, and if you don't remember, the clip variable will be the climbing animation, so the clip.length is going to be equal to the climbing animation's time in seconds, but if we didn't assign a value to clip, then we hard-coded a value of 0.5f as animation time, and animation time will either be clip length or whatever the hard-coded value is. And then I subtract a fraction of that time off, because I always found when I didn't do this, it would cause the player to jitter a little bit when they got on top of the ledge, and shaving just a little bit off the time made that transition when the player's climbing and you don't have any control of the player, to the point where you do have control again, feel a lot more smooth. Now let's take a look at what happens when we press down when we're hanging from a ledge. The first thing we do is set the ledge back to null, because of course we're no longer grabbing onto a ledge, so there is no current ledge. Then we set the move bool that I briefly discussed to false, and just a reminder, I'll describe what this bool does later this video. Next, we set the character.grabbing ledge bool back to false. We also make sure the animation for ledge hanging is no longer playing. We set the falling bool to true, which is going to prevent the player from immediately grabbing back onto the ledge. We next set the rigid body type back to dynamic, which will apply all the physics forces to the character again and cause the player to fall. We then make sure whatever script is handling horizontal movement logic is re-enabled so we can move again, and then we invoke a method called not falling, so we can have that very, very brief delay between when we press the down button and let go of the ledge, and the falling bool is set back to false. So if we scroll to the bottom of the script and take a look at the not falling method, we can see the only logic in this method is setting the falling bool back to false. Now we kind of touched base on the climbing ledge method that's set up as an IEnumerator, and the logic in this method is a little bit more complicated than I want to take the time to explain, but what this method is doing is it's going to set up a position lerp, which lerp is short for linear interpolation, and that's just a fancy way of saying smoothly transition between two different points over a set amount of time. So the logic in this method will set up the lerp first, and then it'll go ahead and lerp the player's position between the current position and on top of the ledge over the amount of time it takes to play that climbing ledge animation, and then once it's on top of the ledge and it's done lerping, it'll go ahead and set the ledge back to null. It'll also make sure that move bool is set to false. It'll set the character.grabbing ledge bool back to false, and then it'll stop playing the climbing ledge animation. Last, we have this method adjust player position. And what this method is going to do is refine the player's position when they're hanging from a ledge, because depending on certain ledges you may want to have the player hanging from a different point, as well as this method will go ahead and snap the player into the best position when they enter the ledge hanging state. So this method is going to first make sure that the move bool is set to false, and we do this because we only want to move the player one time, and as you can see, the first line of code within this if statement is to set the moved bool to true, which will of course prevent this logic from running a second time until moved is set back to false. So when the logic does run within this if statement, it'll first check to see what direction the player is facing, and of course this if statement is checking to see if the player is facing right, while the else statement is checking to see if the player is facing left. So depending on whether or not you're facing right or left, it'll move the player to the leftmost part of the ledge or the rightmost part of the ledge. It'll then add an additional value that we can optionally set up within the ledge script itself, called hanging horizontal offset, to better refine the player's horizontal position when they're in a ledge hanging state for each different specific ledge type. It also sets the player's position vertically, so that the top of the player's collider is just below the top of the ledge's collider, so that it can continue meeting the parameters for a ledge hanging state and have a consistent position for that ledge type on how the player needs to hang vertically. It'll then go ahead and check to see if there's an optional value within the ledge script, and then add whatever value that is, if there is a value for hanging vertical offset. And that's all the logic within the ledge detector script. As mentioned, the platforms that the player will interact with as ledges will need to have a ledge script. So let's take a look at the ledge script now. The ledge script is only going to contain 2 public float variables, and we'll set these variables up within the inspector window, and then the ledge detector script will go ahead and receive these values when it needs to run the adjust player position method. Now, if you're using the solution that I provided that has a character script, all we need to do now is add a hidden inspector public bool variable to that script, named grabbing ledge. So if you take a look at the character script I have here, the only new logic is setting up that bool. However, if you don't have a character script, then you should have a grabbing ledge bool that you already set up in the ledge detector script, and this bool is really for other scripts that you might add to this solution in the future that would need to know when the player is in a ledge hanging state. But as far as this solution goes with everything that we currently have in it, we're done writing logic. So let's save the scripts and go back into Unity. Next, I'll briefly touch base on the Animator component and show you how we can have the right animations playing when they should. You're going to first need to make 2 different animations, one for ledge hanging and one for ledge climbing. So if you need some time to make those animations, go ahead and pause the video here. I already made the animations before I started filming this video, so let me go over the 2 different parameters we need to use to trigger the animations. We need to add 2 new bool parameters, and within this script we have these bool parameters named as ledge hanging and ledge climbing, so it definitely makes sense to name the parameters that. And then I have transitions going from any state to the respective animations. In both of these animations, I unchecked the box for can transition to self, which is found under the settings tab when you click on the transition itself. While we're in the settings tab, let's also set the transition duration to 0 seconds, so that the player immediately transitions in and out of these animations when it needs to. Let's take a look at the conditions for both of these animations now. For the ledge hanging animation, I have the condition set as ledge hanging is true and ledge climbing is false. And then for the ledge climbing animation, I simply have ledge climbing as true. Now I also have a blend tree that handles vertical movement, so for the transition to that blend tree, I have ledge hanging and ledge climbing both set to false. I also have ledge hanging and ledge climbing both set to false for the idle animation transition, and then I have ledge climbing set to false for the walk animation. Now before we can test everything out, we need to set up the ledge locator script in the player. For the clip variable, I went ahead and plugged in the ledge climb animation, and then for climbing horizontal offset, I have that set as 1. Last, we want to make sure any platform that the player should react to as a ledge has a ledge script attached to it, so that when the player runs into one of those platforms, the ledge locator script knows it's a ledge, and then can go ahead and handle the rest of the logic from there. I'm going to test out both of these ledges with 0 values for horizontal and vertical hanging offset, because I want to show you during a playtest how we can use those values to refine the player's position when they're hanging from a ledge. It's definitely something that you want to playtest and find the perfect value for, and depending on how wide each platform is, you might want to adjust it for each specific different type. Now with everything set up, we can go ahead and finally playtest, and as you can see, when I jump up and touch the ledge, the player enters a ledge hanging state, and as you can see with this animation, having a value for hanging vertical offset would really help make this look a lot more realistic. So let me change the value for hanging vertical offset to 0.45, but while we're hanging here on the ledge, let's go ahead and press up. The player quickly jumps on top of the ledge, and it doesn't matter if the ledge's position is to the right or left of the player will react to both ledges the same. Now let's jump back on the ledge where we have the adjusted hanging vertical offset value, and now with the new value for hanging vertical offset, the player is in a much more appropriate position for the animation, and the animation looks a little bit more realistic, so you'll definitely want to make prefabs of ledges so that you can always have the most realistic animations for each different ledge type. Also, if I'm hanging from a ledge and I press down, then the player will simply fall from the ledge. One thing I need to mention about this solution, the ledge detector script first makes sure that the top of the player collider is below the top of the ledge collider, as well as the top of the player collider is above the middle of the ledge collider. And if you're trying to use the ledge script on a vertical ledge or an especially wide ledge, it'll have the player enter the ledge hanging state in a position lower than you probably want the player to enter that ledge hanging state from. So if you are planning on using this solution with a vertical ledge or a wide ledge, you're probably going to need to have a separate game object at the top of those ledges that would be a skinnier platform for the player to grab onto, so that the player can't grab onto the top of the ledge if they can only jump about halfway above it. Alright, that'll go ahead and wrap up this video. If you learned something from the tutorial, or you found this video useful, please consider liking the video, and if you're not already subscribed to my channel, Also, please consider subscribing, as I will only upload top-tier proven solutions within Unity. If you're using the information in this video to make a Metroidvania-style game, also consider checking out my course on Udemy, Metroidvania Toolkit, in which I discuss everything you need to know to create a Metroidvania-style game. It's one of the highest-rated courses on Udemy, and I have a special discount on my website that can bring the cost of the course to about the same price as you would normally spend on lunch. But regardless, thanks so much for watching the video. I look forward to seeing you in my next one. Have a great rest of your day and take care.